Hello class, today we will be going over chapter 2, which is displaying and describing categorical data. Now the three rules of analyzing data are easy to remember. Number one, make a picture of your data so people can understand it better. Things may be revealed that are not obvious in the raw data. These are things to think about. Number two, make a picture. Important features and patterns start to show up when you look at a picture of the data. You may also see things you didn't expect. And number three, make a picture. The best way to tell others about your data is with a well-chosen picture. It's the best way to present your data to people that aren't experts in the data. It lets them see a visual representation of what you're trying to tell them. That's why all three of them are make a picture. It's a very, very important thing in stats that you're able to visualize the data that you're trying to portray to people. Now, categorical data is usually compiled using frequency tables. And they make a pile. We pile the data by counting all the data values together for the category of each interest. So remember, categorical data is basically just a category that you put people in, and you can take account of how many people fit that category. It could be like a preference, like a survey, or it could be like this right here. And this particular one right here, they're talking about the people that were on the Titanic. So a frequency table lists a category for a categorical variable and gives the number of observations of each. So there were 325 people that were first class customers on the Titanic, 285 that were second class, 706 that were third class, and 885 that were crew members. Now, a relative frequency table is similar, but it gives the percentages of each category. So, relative frequency lists each category for a categorical variable and gives the percentage or proportion of observations of each. So what you would do is take the number of people that were first class and divide it by the total number of people on the ship, and you get 14.77%. So if you look back at that other slide, you can look at the number. Like for second class, it'd be 285 divided by everybody, and you get 12.95%. So the way to calculate those is just take the number of people that fit that category and divide it by the total number of people that you're talking about, and you get the percentage. As you can see, 40% of the people are crew members on the ship. And this is good data to know right here, because when you're able to visualize it as a percentage, it tells you more about the data. Now, frequency tables, let's keep going with that. Both types of tables show how cases are distributed across the categories. They describe the distribution, how things are spread out across the groups of the category variable, because the possible categories and tell how frequently each occurs. Relative frequency is just a way of saying percentage. So it may sound a little fancy, but it's just saying percentage when they say relative frequency. Proportion is also another word for percentage. And both ways are just a way of telling us how frequently it occurs. So let's take a look at some of the pitfalls of visualizing your data. And you'll see this on a lot of news channels and stuff like that, where they will visualize it wrong. So you might look at this and think that it's a good way to show the number of crew members on the Titanic, but see if you can spot what's wrong with it. Maybe pause it and see if you can come up with it, and I'll talk about it when you come back. All right. So on this picture, the problem here is these don't correctly represent the number of people in each category. Like there are 300 people, there were like 300 people in second class, and there were 900 crew members. So this one, second class, versus the crew membership should be about 3 times bigger. If you look at those two, that is like 9 times bigger. It's so much bigger than the second. If I look at these pictures right here, it looks like the crew members, there's more of them than all the other ones combined. That ship looks bigger than all three. All three of these ships could fit inside of this one. And the reason is they used two-dimensional pictures to represent one-dimensional data here. You see what I'm talking about? Like this, the 300, well, this one right here, second class, the 300 should go out that far, but this one should go out that far too, but it shouldn't get taller, right? It should just be 3 times bigger, and they should be like the same height. But this one, they made it like 3 times wider and 3 times taller, which made it 9 times bigger than this one. So even though the crew is only 3 times bigger, the picture is like 9 times bigger. So that can be deceiving. You got to watch the way you do this. Let me show you some other misleading stuff, and you'll see this in politics a lot. And what they'll do is they'll just cut off part of the graph. So over here, this is misleading. They say, if the Bush tax cuts expire, this was back when George W. Bush was president, and they were talking about expiring the taxes when Obama came in. The top tax rate will raise from 35% to 39.6%. Now that doesn't sound like much, and it isn't. It's, a little 4.6% difference, which is a little more than 10% of the total. But if you look at this graph, since they cut off the bottom and they started at 34, it looks like they're like, quadrupling, quintupling your taxes when you do that, but that's not true. So this is not a good representation. It's very deceiving. And you'll see this in politics a lot. They'll be deceiving to try to prove their point. But you got to be careful about that. This is the proper way to do it over here, more accurate. You have to start at 0 so we get a true perspective of how much bigger 39.6 is than 35. And it's not that much bigger, right? It is a little bigger, but it's not that much bigger. So this is actually useful data. This is misleading nonsense. Okay, so what we just saw on those last 2 slides is called the area principle. Oops, let me go back. The area principle means that we saw like the one with the ships. It made it look like, the vast majority of people on there were crew members, when it was actually less than half the people were crew members, right? That picture was too big that represented the crew members. When you look at each ship, you see the area. When you're looking at things, you notice the area, how much space they take up. And if they take up more space than they should represent, then something's wrong with your graph. Your graph is not true to the true data. So this violates the area principle. The area occupied by a part of the graph should correspond to the size of the value it represents. When you increase the value, it should be represented by an increased area. Like the Bush tax cuts one was also deceiving, right? When you go up by just like 4%, 4.6%, your area shouldn't be like 5-6 times bigger when you're just going up from 35 to 39. 39 is not 5 or 6 times bigger than 35. So you're just using a misrepresentation of the data, and that's called the area principle. And you definitely need to follow the area principle when you're doing statistics. Next, I'm going to look at bar charts. A bar chart displays the distribution of a categorical variable, and it shows the counts, and see how it shows them accurately. They represent the area they're supposed to represent, like this one is about 3 times bigger than that one. Whoops. Let's go back there. The crew one is about 3 times bigger than the second class one, and it's accurately depicted right there. So it stays true to the area principle, and the number of observations for each categorical data. It has the number of observations for each one, and it represents the bars should not touch each other either. It helps it be nice and clear looking when the bars don't touch each other. Keeps them separate. Now, a relative frequency bar chart just shows the percentages. It goes from 0 to however high you need to go, at least as high as the highest one in your data. which was around 40% for the crew. It displays the relative proportion of observations for each category of the categorical data. All it does is it replaces the counts, like how many times it happens, with the percentage of times it happened. And it doesn't look much different, does it? It should look almost exactly the same. As long as you scaled it correctly, it should look about the same. See, the crew is about 3 times as big as second class, and that is accurate. The bars also should not touch on these as well. Pie charts, when you're interested in parts of the whole, a pie chart is a really good display of choice. Like when you want to get a good visual representation for what percentage of crew are there. See how you can see how much of the pie the crew takes up. So pie charts show the whole group of cases as a circle, and they slice the circle into whose size is proportional to each fraction, into like these little pieces that are proportional to each fraction. It shows a whole. It divides it into categories showing a wedge of the circle whose area corresponds to the true proportion. So like this wedge for crew is about 40% of this entire piece of pie right here. Pies are best used as a representation of proportion or percentages. Now this one they really should have shown the percentages. Anytime you use a pie chart, it's good to at least display the percentages on here, because when I think of pie charts and when you think of pie charts, you should be thinking percentages most of the time. Okay, that is it for the first part of Chapter 2. You can go ahead and work on your stuff and move on to the second part when you are ready.